Okay, so today we're going to start on infinite series, whether they converge or diverge. Okay. Now, so far we've been working on an infinite sequence. So just going from the previous classes, well, the previous class, I think we only covered it in one. An infinite sequence would just be separate terms. So you have the first term, then the second term, the third term, and then it just keeps on going. Now, infinite series, instead of having the separate terms, you're just adding them all together. Or just series. You don't really hear the term infinite series a whole lot. That's just the first term plus the second term plus the third term. Uh-oh. And it keeps on going to where eventually you pass some nth term and it still keeps on going to where it's the sum from n equals 1 to infinity of a sub n. Okay, so in other words, the sequence is a list of terms, and a series is the sum of terms. Okay, so we're going to look at what they call a partial sum. Okay, so partial sums. It just represents a small portion of the series. Okay, so we know for our series, it's just say term 1, term 2, plus term 3, so forth and so on and so on. For an infinite series, if you have the first term, that's S sub 1. If you have your second partial sum, that's the first term plus the second term. And then so forth, bless you. For the third partial sum, the first term plus the second term plus the third term. And it just keeps on going like that until you get to your nth partial sum, which, if you look at the pattern, is just the first term plus the second term plus the third term plus the fourth term, and it keeps on going and it keeps on adding until you get to the nth term. All right. Any questions on that so far? All right. Okay, so we can pretty much say that if the sequence of partial sums converges, let's say to some number, we'll call it S just because it's for partial sums. some number S, then we'd say that the series actually converges. So then the series, the sum of a sub n from n equals 1, could be n equals 0. Either one is just fine. That also converges. All right, where in this case, S equals the sum of the series. Which is your A1 plus A2 plus A3 all the way to some AN, and it keeps on going. So you're just adding all of them together. And we just gave it some random variable to represent the sum. So let me move this up a little bit. Okay. So of course, if it diverges, then the series diverges. Right, so let's say, for example, if we have let's say if we want to evaluate the series, sum from n equals 1 to infinity of 1 over 2 to the nth power. To show its convergence or divergence using partial sums. Okay. The first thing we want to do, we want to find the pattern of the partial sums. So find the pattern of partial sums. Okay. So that means we start off with our first partial sum, which is really just plugging in 1. Actually, let me write that down here. N equals 1 to infinity of 1 over 2 to the n. S of 1 is just your first term. So if we actually did this at n equals 1, it would be 1/2. N equals 2 would be 1/4. N equals 3 would be 1/8. N equals 4 would be 1/16. And it keeps on going from there. So our first partial sum is just our first term, which is 1/2. Now, our second partial sum will be the sum of our first two terms. So that's 1/2 plus 1/4. So if we made this 2 over 4, that would end up being 3/4. Now, our third partial sum is just 1/2 plus 1/4 plus 1/8. So if we added all those together, getting our common denominator and all that good stuff, it would be 7/8. Okay, so this would just keep on going to how many you need before you can kind of figure out the pattern. So if we looked at all of these answers, you can see you may have to go one more if you wanted to find the pattern. But this kind of looks like 2 to the nth power minus 1 over 2 to the nth power. Because as you keep going, the numerator is always 1 smaller than the denominator. Okay, so that means our S of n is going to equal 1/2 plus 1/4 plus 1/8 plus plus some 1 over 2 to the n, which eventually would give us that formula. Okay, so now we have to find the limit of that partial sum. So if the limit of that partial sum converges, then the series converges. But if it diverges, then the series diverges. So we find the limit. Oh, bring that up a little bit more. Okay, so that means we have the limit. You can use x or n or whatever you like. So as x approaches infinity of 2 to the x minus 1. Uh-oh, that looks a little bit big there. Over 2 to the x. Like I said, if you want to use n, that's perfectly fine too. Okay, so as it approaches infinity, you actually end up with infinity over infinity. So you have a really big number minus 1 over a really big number, which is still infinity over infinity. So remember, that's an indeterminate form. So we can use L'Hopital's rule. Okay. So that means we take the derivative of the numerator and denominator. Say that 5 times fast. So you have the limit as x approaches infinity of the derivative of the numerator, 2 to the x minus 1, over the derivative of the denominator, 2 to the x. Okay, so this actually equals the limit as x approaches infinity of 2 to the x times natural log of 2, since the derivative of negative 1 is just 0. So bring that up a little bit. Here we go. Over 2 to the x of natural log of 2, which just gives us 1. So we have the limit of 1 as x approaches infinity, which is just 1. So the series converges, and the sum is actually converging towards 1. Yes.
So what's the easiest way to find what partial series converges to 1? Like, or is equal to 1 at some point? So like.
Well, they won't all equal 1. It's just,
So it's gonna
yeah,
oscillate, like
yeah.
you said?
Sometimes they oscillate, or sometimes it just keeps growing just infinitely. So if you end up with a limit that's infinity, then it diverges. Or if you get the partial sums that bounces from 3 to 0, 3 to 0, or negative 1, 1, negative 1, 1. So if it just bounces back and forth, then it diverges. And funny you should bring that up, because that's the next example.
Oh.
Yes.
Can we have just divided the 2 terms, or the numerator and the denominator?
Oh, yeah, if you just want to divide them all by 2 to the nth power, you could have. I just look for an excuse to use L'Hopital's rule. All right, anyone still writing? Okay. Okay, so let's say, for example, examine the partial sums to determine the behavior of the series, say the sum, n equals 1 to infinity, of 20 to the negative 1 to the nth power. Alright, so for this one, first thing we do is we look at a pattern of our partial sums. So S of 1, oh, actually if you wanted to, you could put a couple of them out first. But you don't have to. Well, I'll do it that way. More than one way to do it. So that would just be 20 times negative 1 to the first power, which is negative 20. Your second partial sum is just 20 times negative 1 to the first power plus 20 times negative 1 squared, which gives you negative 20 plus positive 20, which is 0. Your third partial sum is 20 times negative 1 to the first power plus 20 times negative 1 squared plus 20 times negative 1 to the third power. So you have negative 20 here. If you have a positive 20, negative 20, you're left with a negative 20. So if you have your fourth partial sum, which pretty much you can see the pattern here, but we'll go one more. 20 times negative 1 to the first power plus 20 times negative 1 squared plus 20 times negative 1 to the third power plus 20 times negative 1 to the fourth power, which again is 0. Now if you wanted to, you could also add it this way. You don't have to add them all like that. Here you could have just said the second partial sum plus add the third one. Or you could have said the third partial sum, which was negative 20, then add the fourth one. So you could have done it like that also. Okay, so we can see that it oscillates between negative 20 and 0, negative 20 and 0. If you go all the way to infinity, it'll keep bouncing back and forth. So if it bounces back and forth, then we know the limit doesn't exist. It diverges. Okay. The partial sum, those sums, oscillate between negative 20 and 0, so it diverges. All right, any questions on this one? All right. Oh, anyone's still writing? Oh, leave it up for a few more seconds. Okay. So let's say, for example, using partial sums, find the behavior of, let's say, the sum n equals 1 to infinity. Oh, that infinity looks a little bit rough. there we go, of 8 over 6n squared plus 6 times n. And if you wanted to for this one, you could rewrite it as 8 over 6 times the sum of n equals 1 to infinity of 1 over n squared plus n. All right, and I'll give you a few minutes to start on this one. trying to do this by hand, you'll give yourself a headache. You definitely will want to use a calculator for this one. 'Cause some of those sums can get a little bit wild. Grab my pencil. Here, see if you add the key over there, that would be 4, 6 times 4, 6. So this one, that's your 12. If you actually add those together, it would be 3/4. And that one, can't remember what it was when I added it together. 4/5. There you go.